If there is insufficient airflow, then the non-fluidized product will move as a single mass without proper separation. Slowly increase the volume of air. Once fluidization and stratification have occurred, then the correct air volume will maintain the layered effect without disrupting it. Excessive airflow is characterized by aggressive boiling or heaving of the product off the deck. When either condition is observed, air volume should be reduced immediately. At the initial side slope setting, you will probably notice that there is a corner of the deck between the light discharge and middling hopper that will not fill with product. We call this the magic corner. By paying particular attention to the magic corner, you will be able to optimize the final adjustments of the Pegasus. If necessary, slowly raise the side slope of the deck to shift movement of product towards the magic corner. Continue to slowly increase the slope until the material is 1 to 2 particles deep in the magic corner. With experience, you will learn to use the eccentric speed control to optimize the movement of product on the deck. Slowing the speed will also cause material to shift down towards discard and increase the depth of material in the magic corner. Conversely, increasing the speed will pull material up the side slope towards the heavy product discharge. This will result in less material occupying the magic corner. When the side slope and eccentric speed are properly set, then the magic corner should be completely filled with product that is 1 or 2 particles deep. The number one goal of a gravity table operator is to produce a quality product that meets specifications. Once this is confirmed, then you should begin fine-tuning the table settings to minimize the discard of otherwise good material. Watch the flow of material over the top of the skimmer at the light product discharge. Adjust the height of the skimmer, if necessary, to allow only the obviously bad product to fall into the discard hopper. The skimmer can be adjusted up or down on either end to match the depth of product adjacent to it on the deck. Slight adjustments of the skimmer, together with any change in the eccentric speed, can have a big effect on reducing the discard percentage. If your Pegasus is equipped with the optional rerun conveyor, then begin with the discard and middling splitter set to about the middle of the hopper. Observe the product appearance in the magic corner. If damaged product begins to fill the corner and pushes out towards the heavy product discharge, then the middling splitter must be adjusted to allow more product to go into the discard hopper. Once you move the splitter, you will be able to immediately see the decreased flow in the rerun conveyor. Remember, your goals as a gravity table operator are to first make final product that meets defined quality standards, and then to meet those targets while minimizing the discard of otherwise good product. The Pegasus Gravity Table is a powerful tool that will help you achieve those goals, but you must carefully monitor final product quality and discard rates to verify that all machine settings have been properly adjusted. The ideal condition for efficient density separation on the Pegasus is when normal deck load distribution is reached. The product will discharge uniformly along the heavy, light, and middling discharge rails. There should not be any bare or overloaded areas on the deck. Once this condition is achieved, then you can fine-tune the density separation by making slight changes to the various settings. In the following videos, we will illustrate the effects of improper gravity table settings. Learning to recognize these conditions and taking the steps needed to correct them will help you to become a better operator of the Pegasus gravity table. When there is an excessively high rate of product movement towards the heavy discharge, you will likely achieve poor quality results. Note that there are many layers of particles exiting the table along the discharge rail across its entire length. To correct this condition, first check to see if the magic corner is covered by a single layer or two of product. If it is bare, as shown here, then you should slowly increase the side slope. This will slow the climb of product up the deck and fill the magic corner as material shifts downward. Heavy product discharge will also shift downward. For a less drastic adjustment, you could try decreasing the speed of the eccentric drive. This will also tend to cause material to shift downward and fill the magic corner. Increasing the airflow can also help to move product towards the magic corner, but it should not be increased beyond the point at which it disrupts proper stratification. If adjustments to the side tilt, eccentric speed, and airflow cannot correct the problem, then you should consider reducing the product flow rate onto the deck. When there is an excessive rate of product movement towards the light discharge, then you will likely experience unnecessary loss of otherwise good product. This condition is characterized by having more than a 3-kernel depth in the magic corner. If this is occurring, then the heavy product discharge is also likely to be lighter towards the higher side of the deck, as seen here. The first option to correct this problem would be to increase the eccentric drive speed. This will move product up the slope towards the heavy discharge and reduce the amount of product in the magic corner. If additional adjustments are necessary, then slowly reduce the side slope to allow more product to move away from the light discharge and climb the incline more rapidly. Lowering the side slope should reduce the amount of product in the magic corner. Decreasing the airflow will also tend to make product climb more rapidly towards the heavy discharge. Be careful, however, that airflow is not reduced to the point where fluidization and stratification are compromised. If the heavy product discharge is relatively even across its width and the adjustments described above do not reduce the amount of discard, then you slowly reduce the feed rate until the material in the magic corner is only 1 or 2 particles deep. The Pegasus has been designed to provide for extended hours of maintenance-free operation. As with most machines, however, periodic maintenance will be required. Do not allow the air filter screens to become clogged. The best time to clean the screens is when the Pegasus is not running. Lightly tap and sweep the screen surfaces to dislodge dust and debris. Sweep up any material that falls to the floor prior to restarting the fan. For the Pegasus to operate at peak efficiency, the deck cover must be free of material that can clog or blind the pores on the cover. Use a soft bristle brush to sweep off the deck while the fan is running to prevent smaller particles from falling into the deck. If it becomes necessary to clean the internal air chest or underside of the deck, then please refer to your user's manual for further instructions. All bearings on the Pegasus must be periodically lubricated with high-quality lithium grease. There is also standard maintenance that is required for the eccentric drive's counterbalance system. Again, you should refer to the user's manual for further instructions on completing these important procedures. This concludes the Pegasus Gravity Table training material. We hope that you will continue to use this disc as a resource whenever the need arises. Without question, however, there is no substitute for hands-on experience. Use the knowledge that you gain from viewing this material and the experience from running the machine to become a proficient Pegasus gravity table operator. The combination of your expertise and the proven capabilities of the Pegasus will result in improved efficiencies while meeting or exceeding product quality standards. If you have any further questions or problems arise during operation, do not hesitate to contact ARROWCORP. Thank you.